Okay, guys, we are starting the last part of the year here. And while they're in two different chapters, part of it's in chapter 10, part of it is in chapter 11. Surface area and volume are very similar in that they deal with three-dimensional figures, okay? And so they're polyhedrons, meaning that they are figures that are made up of polygons, and then outside of that, we'll also deal with cylinders and cones. So we'll look at this one thing at a time. Today we're doing surface area, and surface area is what it sounds like. Surface area is if you had a three-dimensional figure. For instance, if we look at the ones we have written here, or drawn here, the question is, what is the total amount of area? In other words, if I were going to paint the outside of this wedge right here, I would have to paint the top, I would have to paint the bottom. I would have to paint kind of that side that's in the back we can't really see there. I'd have to paint this side over here that we can't really see. And then I'd have to go through and I'd have to paint the front of this box as well, right? So that prism would have 5 different sides. And so the idea is you calculate the area of all 5 sides and you add it together. That's all it is, okay? It's as simple as that. Now, there are some nuances here that I wanted to walk through with you. And so let's go over some definitions. So you guys always know when we start a new section, we have a new definition. So I'll read this to you quickly, but you can read. I just want to explain this as we go through. Prism is a polyhedron with 2 congruent parallel faces called bases. So you'll notice here, this face and this face are parallel to each other. Therefore, that would be a pentagonal polyhedron, meaning that we name these after the shape of their bases. And that it would be a base even if it was sitting like this. So just because it's called a base doesn't necessarily mean it's what's touching the bottom, okay? The base is what the 2 parallel sides are. This one right here would be a triangular prism. Now, lateral faces are the faces that kind of connect those 2 parallel sides. So they would be, in this case, there would be 5 vertical faces here. If it was laying down, it would be this face, and the other ones around there that we cannot see. The altitude or height of a prism is the distance between the bases. So even though this is laying down, that technically would be altitude or height. In this case, when it's standing up, that would be altitude or height. Right prism simply means that it's a right angle, that they're straight up and down like this one. An oblique prism simply means that the lateral faces are not rectangular. So there's 2 things that we want to calculate. Sometimes they just want us to calculate the lateral area. So if I wanted you to calculate the lateral area of this prism here, I would only want the back, the right side, the front, and the left side. I would not want the top or the bottom. Sometimes when you're calculating things for boxes or packages, we really just want lateral area. We don't really need the end caps. For instance, if we were looking at putting a label on a soup can, there's not a label on the top or the bottom of the can. It's just on the side, which is the lateral area. Okay, we'll talk about that on a cylinder in a second. An easy way to calculate lateral area is to figure out what the perimeter is of your base. Find out what the perimeter is of your base. So in other words, add all those up and then multiply that by the height, right? So that would get you the lateral area. However, if you want surface area, you would also have to go back and calculate the top and the bottom as well. So you have to add the 2 bases. So the formula for surface area is all the lateral area plus 2 bases. Let's take a look at a few examples. Okay, guys, so for example 1, we have a very basic right prism here. Now, keep in mind, we're not doing volume. I know some of you guys have done volume before. That's not what we're doing here. We are doing surface area. So we literally have to find the area of every side of this polyhedron. If we look at this, there are 6 sides. There are 6 sides. We have a top and a bottom, we have the right side and the left side. We have what I would call the front and the back, the way this is oriented. So if I look at the top side, the area of the top side here is 8 times 4. So 8 times 4 would make the top 32 square centimeters. Well, the top and the bottom are the same size. So top and bottom together would be 64 square centimeters. The right side and the left side, when I look at the right side and the left side, well, that's 4 times 5. So that would be 20 square centimeters. Well, if those are the same, if those are congruent, 20 square centimeters and 20 square centimeters would be 40 square centimeters. And then if I'm looking at the front and the back would be 8 centimeters by 5 centimeters, or 40 centimeters squared for the front and the back. There's 2 of those. And so when I double that, I get 80 centimeters squared. And when I add all that up, I get 184 square centimeters. We move on to our second example, and a lot of times with triangular prisms, you're going to be given kind of a tough situation. So here's what I'm saying. Let's look at the sides that we have. We have a top and we have a bottom, right? And the top and the bottom are congruent here. And so that is a triangle. So that'd be 1/2 times the base, which is 3, times the height, which is 4. Notice this is a right triangle. So if I look at that right triangle, this would be 3, that would be 4. So when I do 1/2 times 3 times 4, that would be 6. That would be 6 centimeters squared for one triangle, but I have 2 of those. So I'm getting 12 centimeters, right? 12 centimeters squared. So I have 2 of those. Now I've got to figure out each of my sides. Okay, cool. So let's try to do the side that's kind of back into the left. So I go to do this side over here, which is back into the left. Well, that's simply, so I'm going to circle this too so don't forget that's the top and the bottom. So we'll say the left face here is going to be 6 times 3, because it's just a rectangle. So it's going to be 18 centimeters squared. Okay, now let's do the one that's back into the right. Well, that's just 6 times 4. So the one that's back into the right face would be 6 times 4, or 24 centimeters squared. Okay, so I've almost got every side now. Now all I have to do is find this front face. Right, so I'm going to find this front face, the one that's staring right at us, that's closest to us. And so when I try to find this face, this one on the front, that's easy. That's just going to be 6 times... Uh-oh, what's the problem? The problem is I don't have that length. I don't have how wide this is. So we have to actually go back and notice this is a right triangle. A right triangle we could use the Pythagorean theorem on. So if I want to call that h, I could say 3 squared plus 4 squared equals h squared, or 9 plus 16 equals h squared equals 25, and the square root of that is 5, right? And some of you guys might have noticed that this was a 3, 4, 5 triangle because of Pythagorean triples, so you could have saved yourself all that time if you recognize that shortcut. So now that I've got that, the front face is going to be 6 times 5, which is 30 centimeters squared. The final thing that we need to do is to add all those together. So 12 plus 18 plus 30 plus 24, that would be 84 centimeters squared total when I add up all the faces. So the method that I encourage you all to do is almost to ignore that lateral area formula and just account for the area of each face individually, and then just add all those together as a total sum at the end. Okay, guys, so one more shape we're going to look at, or one other type of prism we're going to look at, is a trapezoidal prism. So the first thing I'm going to do is I'm going to look at the front and the back, right? So I'm going to do 2 of these, right? But what is that? That is a trapezoid. So 1/2 B1 plus B2 times height. Now keep in mind, we're talking this height right here is not the altitude. It's not 12. It's the actual height of the trapezoid. So the trapezoid is 1/2 2.8 plus 8.1 times 3. So that would be 1/2 times 10.9 times 3. So one of those trapezoids is 16.35, but I know I've got two of those because there's a front and a back. So I just multiply that by 2, and I get 32.7. So that's the front and the back. Now, some of you guys might notice, or what we would call the bases. Now, some of you guys might notice that since we got this 1/2 as part of our formula, and we're going to have two of these, that you could have just did 2 times 1/2. Those would cancel, and so essentially 32.7 is 3 times 10.9, but you don't have to do it that way. You could just calculate for one face and then double it if that's easier. Okay, so now I've got the 3 lateral faces. So I've got to calculate the top face. That's going to be 8.1 times 12, right? Because this is a length of 12. So the top is going to be 8.1 times 12. And that should equal 97.2. I now have the right face, which is going to be 4 times 12. That's 48, but notice that both the right face and the left face are the same. The right face and left face are the same, so I can just double that, and that gives me 96 for the right and the left. And then I'll clean this up a little bit so we can see what we're doing here at the bottom. The last face to figure out is the bottom here, which will be 2.8 times 12, and that would be 33.6. When I add all 4 of these together, which is really 5 faces, right? Or 6 faces, because this is counting for 2 faces and this is counting for 2 faces, right? So 1, 2, 3, 4, 5, 6 faces on this prism. When I add all those together, I get 259.5. There's no units, so we would just say units squared, 259.5. In the second part here, guys, we're going to talk about cylinders. Now, this is not going to take as long as the first part of this video, and we're only going to do one example because the cylinder is kind of nice in that it's got a nice formula, okay? So now when I look at the surface area of a cylinder, what you'll notice I have is I've got a circle at the top and a circle at the bottom. So in a lot of ways, it's like a prism, only instead of having a polygon at the top and the bottom, we have a circle. This one here that I've highlighted, this is a right cylinder. Our other cylinder over here is oblique, just like we have right and oblique prisms. We also can have right and oblique cylinders. If you think about the surface area of a cylinder, let's think about how we would calculate this. Thinking about how we would calculate this, if we took, for instance, a can of soup, and we try to unroll it and lay it flat, like we would create a net. We did this at the very beginning of the year. If I created a net from this shape, I would have 2 circles. That would be the top. That would be the bottom. And this part here would be the lateral area. Well, think about what this length is, right? That is the length around the circle, which is circumference. So that's 2 times pi times r. That's the circumference. So the area of this rectangle, the area of the rectangle would be 2 times pi times r times h. Well, we also have to add the area of the 2 circles. Well, the area of one circle is pi r squared. But how many circles are there? 2. So if I look at the formula for the surface area of a cylinder, it's always going to be the same. It's always going to be 2 pi r squared plus 2 pi r h. So if you look at how this is written here, lateral area is 2 pi r h plus 2 pi r squared. The great thing about this, guys, is it is just a formula, right? So if you're given a certain set of data, you can just use the formula and plug it in. We look at our example here. 2 times pi it says it has a radius of 10 centimeters. So it's just going to be 10 squared plus 2 times pi. What's the radius? Again, 10 centimeters. What's the height? 12. So when I work this out, this becomes 100, and 100 times 2, this would be 200 pi plus 10 times 12 is 120, times 2 would be 240 pi. And so the answer here would be 440 times pi centimeters squared. It's formulaic. The only twist they could possibly give you guys is if they give you a diameter instead of a radius, you would just divide that by 2 before you plugged it in. Other than that, guys, it's pretty straightforward. If they asked us to multiply this out to the nearest tenth, we would get 1,382.30 centimeters squared. So again, this answer here to the right is in terms of pi. The answer on the left is to the nearest hundredth. I hope this helps, guys. Have a great day, and just do the homework problems and upload it. Tomorrow, we find the surface area of pyramids and cones. So we're still doing surface area tomorrow, but we're going to do pyramids and cones. Have a great day.